Speech recognition technology. Have you ever tried to communicate with someone who didn't speak your language and they couldn't understand you? Quite challenging, right? Now imagine trying to communicate with a computer who only understands zeros or ones. This can be done via various machine learning NLP algorithms like follows. First, a person says something to the machine. Then the machine records sound. The machine then turns the audio into text. The NLP system passes the text into components, understands the context of the conversation and the intention of the person. Based on the results of the NLP, the machine determines which command should be executed as follows. Did you know that voice recognition technology has been around for 50 years? But in the recent time, it has gained a boom. Now we have a whole variety of speech recognition software programs that allow us to decode the human voice. It is used in mobile telephony, home automation, hands-free computing, virtual assistants, video games, and a whole lot of other applications. Google Assistant, Siri, has made it a hot topic for a large number of products. So, what exactly is speech recognition? Speech recognition is an interdisciplinary subfield of computer science and computational linguistics that develops methodologies and technologies that enable the recognition and translation of spoken language into text by computers. In short, speech recognition is a technology that allows spoken input into systems. What is automatic speech recognition? It is the use of computer hardware and software-based techniques to identify and process the human voice. It is primarily used to identify words a person has spoken and convert them into computer text. It is also used for biometric authentication, which is done via voice and performing actions defined by the humans. Typically, such system requires pre-configured or saved voices of the primary users. The users need to train the system by storing speech patterns and vocabulary into the proper system. How does speech recognition work? In order to set up a voice recognition technology, we'll need to send a few voice samples to the device, which will convert these samples into a digital waveform that is unique to us. Think of it as a sound fingerprint. There is no other voice like it in the world. Once we have set up and activated the device, usually with a passphrase like "Hey Siri," "Okay Google," this becomes the input to the device. It will then turn the analog sound waves of the voice into digital waveform. A waveform is basically a string of numbers. Then it is converted into a spectrogram, which is broken up into frames. These frames are processed to find the phonemes. Phonemes are the letters of the spoken language that each frame contains. The phonemes found in the frames are then compared to the phonetic dictionary to identify what's being said. No speech recognition algorithm will ever be completely accurate, but we improve the accuracy using hidden Markov models and neural networks, which assign probabilities to the phonemes depending upon their location and the relationship. Let us look at the speech recognition process. First of all, we take a waveform, split it at utterances by silences, and then try to recognize what's being said in each utterance. To do that, we want to take all possible combination of the words and try to match them with the audio. We then choose the best matching combination. The important concepts to be kept in mind in this process are: first of all, it's the concept of features. Since the number of parameters is large, we try to find the most optimal of them. We divide the speech into number of frames, each frame typically of 10 milliseconds length. We then extract 39 numbers that represent the speech. It is called as the feature vector. Second is the concept of model. What is a model? A model describes a mathematical object that gathers common attributes of the spoken word. Three important things while choosing a model are: how well does the model describe reality? Can model be made better of its internal model problems? How adaptive is the model if the conditions change? Here, the model of speech we use is the hidden Markov model or the HMM. It is a generic model process which is described as a sequence of states which change each other with a certain probability. HMMs have proven to be really practical for speech decoding. Third, and the most important, is the matching process itself. Since it would take a large amount of time to compare all feature vectors with all the models, the search is often optimized by using different various tricks. Let us look at Amazon's Alexa as an example of speech recognition. Alexa is one of the most popular voice assistants out there, which is housed in Amazon's Echo Smart Speaker and Echo Show, which is a voice control tablet, and Echo Spot, which is a voice control alarm clock. Amazon's Alexa adapts to your voice over time, offsetting any issues it may have with your particular accent or dialect. Alexa skill set allows third-party developers to create apps and tap into the power of Alexa without ever needing native support, therefore outperforming Siri, Google, or Cortana. Another huge selling point for Alexa is its integration with smart home devices such as cameras, door locks, entertainment systems, lighting, and thermostats. With Amazon's Smart Home Skills API, you can enable customers to control the connected devices from tens and millions of Alexa-enabled endpoints. If you ask Alexa to reorder your rubbish bags, she'll go through Amazon and order them. The fact that you can order millions of products of Amazon without ever lifting a finger is a natural and unique ability that Alexa has over its competitors. What is the future of speech recognition? Throughout the history of computing, user interfaces have become progressively natural to use. First came the screen and the keyboard, then the mouse and the graphical user interface, and lastly, in recent time, came the touchscreens. The next step will most likely consist a mix of augmented reality, gestures, and voice command. Because isn't it easier to ask a question than to type the same thing out? Google and Amazon are looking to integrate voice-enabled AI to capable of analyzing and responding to human emotions. The ultimate aim is to make possible for a computer to simulate natural conversations like we humans do. And with each passing day and with every research being made, we are getting closer to this. Well, the future surely looks good for our smart assistants. And now that you know how your Siri or Alexa works, I hope you will make most of it. Thank you.